Okay, 4.3, solving x squared plus bx plus c equals 0 by factoring. Here's the deal. You are going to be good at 4.3 if you know facts of multiplication. If you know your times tables, you're going to do well at this. Or factoring, okay? Factoring is easy. There are special cases we're going to learn about where there are like special ones that have special patterns, and we're going to just have to memorize those patterns when it comes to specific ones, like difference of squares and perfect square trinomials, which Mrs. McCain said she introduced you to in Algebra I.
Yeah, I remember that.
So we'll talk about those because those are special cases that you just memorize. There's no way around it. You memorize it, you do it. Otherwise, we're going to have to be able to like break numbers apart and say what multiplies to give me this number, what adds to give me this number, and vice versa. Okay? A monomial is an expression that is either a number, a variable, or the product of a number and one or more variables. A binomial, such as x plus 4, is the sum of two monomials. And a trinomial, such as x squared plus 11x plus 28, is the sum of three monomials. You know how to FOIL, so we're going to unfoil what we're doing.
Can you tell him to share?
It's me.
Oh,
Mrs. Peters.
you should share it.
That's what you
Okay.
That's what you do.
So if I have x squared plus bx plus c, I'm unfoiling it essentially, okay? I'm factoring it and getting it into x plus m, x plus n, okay? Where m and n are the middle terms, so I say what adds to give me that, and the outside is what multiplies to give me that.
That's tough.
Okay. That's just a brief, like, summarization, I can't talk, of what a monomial, binomial, and trinomial. Let's look at factoring some expressions. Okay, it says factor the expression x squared minus 9x plus 20, factor the expression x squared plus 3x minus 12. So I want to ask myself, what multiplies to give me negative, or what multiplies to give me 20 and adds to give me negative 9? What are factors of 20? 5 and 4. Okay, if I use 5 and 4, yes, that multiplies to give me 20. Yes, I can get that to negative 9. What does that mean my factors are going to be? Negative 4 and negative 5. Boom, you factored the expression.
I'm confused now. Why is it?
Your what multiplies to give you 20 adds to give you negative 9 when you're factoring. So you're breaking it apart.
That's not too hard.
Is that a plus 20 or a minus 20?
It's a plus 20. That's why I need a negative 5 and a negative 4, so that would give me a positive 20 and multiply together.
Can you explain that one more time?
What, okay, so it's, I asked myself, what multiplies to give me positive 20, but adds to give me negative 9?
Oh, so this is just like kind of in your head work?
Yes.
Interesting.
Okay. On B, you're gonna ask yourself, what multiplies to give me negative 12 and adds to give me 3? What are factors of 12?
1 and 12.
1 and 12, can that get to 3?
Nah.
No,
Okay,
3
2
and
and
12.
6, can that get to 3?
No.
4 and 3.
4 and 3, can
That
that
don't
get to 3?
Nah, I don't think so.
What multiplies to give me negative 12
It's a lost cause.
and adds
Oh,
to give me,
sick.
Yeah, 4 and 3.
Wait, no.
what'd you
Yeah,
say?
but I have to add to get positive 3.
What is an add to 3?
What?
Yeah,
Huh?
negative 4 plus, negative 3 plus 4.
Okay, so negative, so 1 and 12 can't get me to 3 when I add them or subtract them. 2 and 6 can't get me to 3 when I add and subtract them. 3 and 4 can't get me to 3 when I add or subtract them. So if that happens, that means that this cannot be,
No
Factor.
solution.
Oh,
yes,
factors.
it's not factorable.
That doesn't make me.
No, what else is the method? Halves.
Oh, thank you.
You're welcome.
Okay, so sometimes you're going to have something that is not factorable. Okay, it's not factorable.
I don't know what this was.
Why'd you underline the
Because I was saying what multiplies to give me positive 20, what adds to give me negative 9. I was just saying we're looking at those numbers.
I want the debit card.
It's not
So
worth
it's-
finding
Alright, give me one.
Yeah, you're multiplying to the one on the outside, you're adding to the one in the middle.
Go, Mama.
Okay, here are two special factoring patterns. One is the difference of two squares, one's the perfect square trinomial. Difference of squares is so easy to recognize, here's why. It's literally only two numbers and there's a minus sign in between them. They're always perfect squares. So it's a squared minus b squared. If you have a difference of squares x squared minus 4. I know x squared is a perfect square. I know 4 is a perfect square. That means when I factor it, it's automatically x plus 2, x minus 2. Because when I factor that, and I would FOIL it out, the 2's would cancel each other out in the center. Okay? Because if I FOIL this right here, you get x squared, right? Minus 2x plus 2x minus 4. So these cancel, giving you x squared minus 4. So a difference of squares means there's a minus sign in between two perfect squares. Okay, that's your clue. And when it is a difference of squares, you just have to know that the pattern is x plus 2, x minus 2, or if it was x squared minus 16, then it would be x plus 4, x minus 4. Or if it's x squared minus 81, what would it be?
X plus 9, x minus.
Right, exactly. Okay?
Good job, Brady.
So difference of squares should take you no time to do because you need to be able to recognize it like that. Okay? The other one is the perfect square trinomial. Okay? This one, you're going to have to recognize as well, because if not, you're going to spend a lot of time trying to figure it out when it's bigger numbers. Okay? Here's what you look for. If the beginning and the end are perfect squares, you have a perfect square trinomial. Okay? So here I have x squared plus 6x plus 9. My beginning is a perfect square. My end is a perfect square. So I take the square root of both and square them, and that's my answer. So x plus 3 squared in parentheses is my answer. That means I have x plus 3 times x plus 3. If I FOIL it, I get x squared plus 3x plus 3x plus 9, which gives me x squared plus 6x plus 9. This is one you have to just see. So I'm going to look. Here's what my first clue to you is this. When you are asking yourself what multiplies to give me this and adds to give me this, check this number out first. If it's a perfect square, you have a perfect square trinomial. If it's not, then I have to actually think and factor.
Check what number?
The last
They
number.
have to be
The
the
last
same.
and first numbers have to be perfect squares. If they are perfect squares, you have a perfect square trinomial.
That's why.
Wait,
And-
6 axes in a perfect square though.
No, that doesn't matter. What matters is the first and the last number.
Oh. Oh.
Okay, so here, 4 is a perfect square, x is a perfect square. That means I have x minus 2 squared, because whatever this sign is what goes in here. Okay, so if I had, let me think about this. If I have x squared plus 12x plus 144, what would that come out to be? X plus 12 squared. Okay, because I keep the sign that's in the middle, and then I just take whatever the square roots are of both of those. Perfect square trinomial. So you have the difference of two squares, tells you exactly what it is. It's two squares being subtracted from each other, and you have a perfect square trinomial. The first and the last are perfect squares, and I can get my answer. Those are two special cases that make it easier, so I don't have to do a lot of math. Okay, factor the expression. I just threw a bunch of expressions up here, and we're going to factor them. The first one, x squared minus 9, what type is that? What's going on there, x squared minus 9? It's a special one. What is it?
3.
81.
It's the difference of squares.
X plus 3, x minus 3.
Thank you, it's the difference of squares. X plus 3, x minus 3 is how I factor this one, because I have to know that it is a difference of squares.
Hold on, wait. I got a question.
Okay, what's your question?
I thought it had that equal -9.
What?
I'm confused now.
It does. What is 3 times -3?
Oh, it's multiplying.
Yeah, you're foiling. That's how you can always check your answer. You can FOIL it back out.
I thought it had to add together.
It does. Is there a middle on this one?
Nah.
No.
Oh.
There's no middle, and this is a minus sign, and both of those are perfect squares, so it is a special case scenario,
Special thing.
which means I have to have that one memorized.
I like the emphasis on your words. Nice voice inflection. 14 out of 15.
Number 5, q squared minus 100. What's going on there?
Q plus 10, Q minus 10.
Yes, because I have a difference of squares.
Yeah,
100 is a
so
perfect
now-
square, q is a perfect square. So it's q minus 10 and it's q plus 10. Okay, over here, I have y squared plus 16y plus 64. Look at the first and last first. Is the first a perfect square? Is the last a perfect square? Okay, so what do I have going on? A perfect square trinomial, which means what is my answer? Yep. Y plus 8 squared. I don't even have to do math. Okay. Here I have w squared and I have 81. Okay.
Is that plus 81?
Plus 81. But it says w squared minus 18w plus 81. Okay. Are those ends both perfect squares? Yes, so what do I have?
-9 and +9?
No.
Oh.
Perfect square trinomial, which means I have what?
Y
W minus 9 squared. Because I take this sign. Okay?
Oh.
Because I take that sign with it.
Wow.
Okay? Is factoring perfect squares and difference of squares easy? Yes, it should take you no time on your homework. Those shouldn't take you any time. Once you recognize them, you should be able to go on. Okay?
Oh boy.
The difference of squares are the easiest to recognize. The perfect square trinomials will be the hardest, but ask yourself before you start doing all the math, is the end of perfect square, is the beginning of perfect square? If you do that, it can save you a lot of time in the long run. Okay? Okay. All of this stuff comes from a quadratic equations, pretty much. You can use factoring to solve certain quadratic equations. A quadratic equation in one variable can be written in the form ax squared plus bx plus c equals 0. You guys are familiar with this. Where a cannot equal 0. That's called the standard form, which I can also graph a quadratic from standard form. Or from what other two forms? Intercept and vertex. Beautiful. Okay. The solutions of quadratic equation are called the roots of the equation. Okay, the left side, ax squared plus bx plus c equals 0 can be factored, and then the equation can be solved using the zero product property, which means when I factor it out, what form do I put it in when I factor it out?
Standard.
No, it's in standard. What form do I put it in when I factor it out? I have like x plus something and x plus something. What form is that in? Intercept form, which is why I can set them equal to 0 and solve to see what the x-intercepts are, okay? So what this is all saying in words is if the product of two expressions is 0, then one or both of the expressions is equal to 0. Algebra says if a and b are expressions and ab equals 0, then a equals 0 or b equals 0. Common sense, okay? And then the example says, if x plus 5 times x plus 2 equals 0, then x plus 5 equals 0, or x plus 2 equals 0. So that is x equals -5, or x could equal -2. You guys know how to solve that. You've done that before, okay? That's nothing new. So then it says, what are the roots of this equation? You have x squared minus 5x minus 36. What should you do to factor this?
Plug and chug.
Nope, I don't wanna plug and chug. That takes longer than doing just factoring.
Wait,
You
I
gotta
haven't
figure it out because of your smart
What
brain.
multiplies to give
Yes.
you -36, but adds to give you -5?
C.
B.
C. C.
You
What
said
you just say?
No, B.
B.
B
C.
would. With these solutions, B would, right? If I factored this out, I would have x minus 9, and I would have x
Ruffle.
plus 4, right? So if I factored this, would you get the same thing? X squared,
Yes.
4x, right? 9x, -9x, and -36. So you would end up getting x squared minus 5, right? Minus 36. Boom. Okay. So your answer would be, what are the roots of this equation? The roots of my equation are 4 and -9.
Wait a second.
What?
Wait, We
Mhm.
studied what you just did.
What are the roots?
Oh,
Actually, my roots aren't 4 and -9. There's a reason why. You guys are thinking differently. My roots are, when it's set equal to 0, what does x equal? What does x equal when this is set equal to 0? 9. What does x equal when this is set equal to 0? So my roots are actually -4 and 9. You have to work backwards and think. Okay, my roots are not 4, -9, because I have to literally set what I've factored equal to 0, and those are my roots. Okay, so x minus 9 equals 0 means that x equals, and x plus 4 equals 0 means that x equals. These are my roots. When you get it down into the simplest form of x equals, that is my root.
How do you know which one is X?
What do you mean, how do you know which one's x?
They're both X.
You don't yet, you're not to that point
Food
yet.
wrappers.
Right now, we're graphing quadratic functions, so both are x, because I'm making that parabola, right?
Oh, it's not.
So where's y?
Okay,
It's
later
not.
on, yes, right now we're not solving.
Just kidding.
Okay,
So,
so when it's asking for roots, that means what does x and y equal? Okay, so I can take my factored form and set both equal to 0 and figure out what the root is. Does that make sense? Can you handle that?
What do you need?
Okay,
What do you need?
What do you do?
okay, here we go. Here's this, let me move this picture.
oh, that hurts so
It
bad.
says, a town has a nature preserve with a rectangular field that measures 600 meters by 400 meters, okay? The town wants to double the area of the field by adding land as shown. So they want to add x by x, okay? Find the new dimensions of the field. How can I set that up to find the new dimensions of the field? What can you do? Put it in what? Yeah, how can I get it, but before it goes in standard form, I have to do
X
something.
plus 400, X plus 600?
Good, yes, Isabel, I'm gonna take this right here, and this is x plus 400, that's the whole length of that. Okay, x plus 400. The whole length of this is x plus 600. Okay? Okay? What do I do from there to solve this?
Foil it.
Yeah, you want to foil it?
Foil it.
Okay, kind of. We're not done yet though, because is this equal to anything?
No.
No, what could it equal?
0.
1,000. 2 times
2 times
400.
Yes.
24,000.
2
2,400.
times 400 times 600, right? Is that what you said?
Doubling the area.
2 times 400 times 600. Because if you find the area of the small one and then double it because x is being multiplied to both ends, okay? You can figure it out from there.
Where do you get 2 from?
That's what I just explained. Because when you have,
Doubling the area.
because you're doubling the area, because it says, they want to double the area of the field in the directions right here.
Bruh, how do they expect us to know that?
So my the original area is 400 times 600, okay? And double means times 2. Now, I have to figure out all the math for this, yes? What is 400 times 600 times 2?
Big number.
You know what? It's
It's like
800.
20,000.
It'd be 800 times
480,000.
1200.
Oh, okay.
So you gotta multiply them together. Oh, she got it.
Okay, now over here I would,
Foil it.
so I get x squared. You get 600x and you get 400x. What's 600 and 400 added together?
1,000x.
1000x. And then I get 400 times 600, which is
24,000.
240,000.
Oh dang, man, that's a big number.
Okay, now, I can't factor this out yet, because what do I have to do first? Is it set equal to 0?
No.
No, so I'm going to subtract 480,000 from both sides.
Negative
Yes.
200.
So x squared plus 8,000 x minus, what's
240,000
240,000, right?
equals 0.
Now, from here, you have to factor. What multiplies to give me 240,000 but adds to give me 100,000, or adds to give me 1,000. That's what we gotta figure out. It shouldn't be very hard because we kind of already did that up top.
600 and 400.
Right. Because 600 and 400 give me 240,000, right?
So X.
Is it minus 600 or plus 600?
Minus.
Either.
Oh wait, I lied. Is it?
Negative
Wouldn't it be opposite, so that minus?
plus.
Oh, it's not gonna be 6 and it's not gonna be 6 and 400 because 6 and 400 can't get me to a positive 1,000 and a negative 240,000.
50,000.
So think about this. 240,000. What are other factors of? Just look at 24 and
12 and 2.
10. Do you get what I'm
12
saying?
and 2.
12 and
2
2.
equals 24.
12 and 2. 12 and 2 can work. Because 12 and 2 can get me to 10, right?
Mm-hmm.
Oh.
So, which one's positive, which one's negative?
12 is, no, yes, 12 is positive, 2
Right.
is negative.
2 is negative. So I'm gonna say 200, right? Negative 200. And I'm gonna say positive
Actually,
1,200. Okay? Now, that means that my zeros are this. X would equal, or X minus 200 equals 0, which means X equals 200. Or X minus 1,200 equals 0, which means X equal, or plus 1,200, means X equals negative 1,200. Now, Mallory had a question earlier. She said, how do you know which one's the answer? We weren't there yet, because we were talking about graphing. Okay, so Mallory, tell me, how would I know which one's the answer of this? If X equals 200 or X equals negative 1,200?
Well, surely it can't be a negative.
Why?
You can't get negative areas.
So, in this case, I know that X has to be 200, okay? So, in this case, X has to be 200 meters. That's what you would have to add to both sides. Okay? So you're gonna use a little bit of logic and some common sense there later. I know that's gonna be a struggle for some of you, okay? But surely, like Mallory said, surely you can't have a negative area.
One pair for everyone now.
Okay. Last thing that we're gonna do, more factoring. Very simple. Find the zeros of the function by writing the function and intercept for it, okay? X squared minus X minus 12. What multiplies to give me negative 12, adds to give me negative 1? 3 and 4, good, like it. What's positive, what's negative?
Positive, negative 3, positive 4.
Good.
Wait, we're trying to get negative
So
1?
then, I want to know what the zeros are.
Wait,
Yeah, I'm right.
What?
doesn't it have to?
Multiply to give me negative 12.
Oh, never mind.
Add
Oh,
to give me
negative 1.
So then X is going to equal what or what? X equals what? No?
Negative 3.
Negative 3 or 4. That's as far as they want me to take it
Why
right
did you
now.
switch the summation?
What do you mean when I say X equals?
No, why is it, shouldn't it be negative 4 or positive 3?
It is negative 4, positive 3.
But you wrote down
You
negative.
mean for my answers?
Yeah.
It's because of this, Brady. When I do this, this isn't the complete answer. What I'm really saying is X plus 3 equals 0. So when I solve, I get X equals negative 3. And I'm saying X minus 4 equals 0. So when I solve, I get X equals 4. Those are my zeros. So my zeros are opposite of what's in here.
Oh, interesting.
Okay, which when we get to leading coefficients that aren't 1, we have to set it up in this way to solve, because you're gonna get fractions and things as your answer.
Okay.
Okay. What about over here? I have x squared, I have 36. Ooh, I know something that goes on right there.
Isn't it just like the
What?
9 and, oh wait.
Perfect square.
It's a perfect square trinomial. This is a perfect square, this is a perfect square. X plus 6 squared. So my zeros are what? X equals negative 6. Those are both of my zeros. I only have one answer for that.
Boom. Boom shakalaka.
Okay?
Boom shakalaka.
This is what your homework is over tonight. Can you handle factoring?
That's it, Monkey.